We have seen that for sorted data, jump search offers good possibilities, especially if we make the jump size equal to square root of n. Then we realize that the complexity of jump search scales with root of n, which is in fact much better than a linear search. However, for sorted data, in fact, there is a much more efficient, much more powerful, and much more popular algorithm known as binary search. The idea in binary search is to go much faster towards the target value till the entire list is searched. And the way we do it is to divide the search space into half at every iteration. So it's kind of like divide and conquer, but very, very, very quickly we get down to the target value. Binary search is extremely, extremely important, extremely popular as well. Sometimes we do it even without thinking in our day-to-day life. Let's take an example to sort of build some intuition. Let's say we have a thick book and we want to quickly get onto chapter 18.4, section 18.4. So let's say, one approach could be the jump search approach, that we go a few pages at a time. But the other approach could be that, look, I am just going to open the book approximately in the middle, right? Now, once I know that, I open the book in the middle and say I find section 9.1. I know that the chapter I'm looking for is for sure in the second half of the book, which means it's after the middle. Now I can keep doing this. I can continue to again open the middle, again open the middle till I get to this chapter that I'm looking for. You'll realize that this is actually much faster compared to doing a jump search. And we are going to quantify this later. We have seen binary search in the past. For example, when we did the number hunt project, let's say I was searching for 37. So I asked I asked if the number is more than 50, less than 50. The moment I know the number is more than 50, less than 50, sorry, I can immediately eliminate the second half of my search range. Then I know the number is more than 26 because again I'm hitting in the middle. Number is more than 26. Well, I know that this part is also taken out. So we saw this in action, that with binary search you could search the number much, much faster. Now clearly binary search is efficient. You can see that because we are dividing the range into half and hence jumping very quickly to the real value. We'll quantify this later. In fact, like we'll see that this is significantly more efficient than linear search and jump search, especially as the list size becomes large. Obviously binary search and jump search both work only on sorted data. But it turns out that, while it's conceptually easy to understand, while kind of easy to sort of talk in general terms on how binary search works, like I said, we do it sometimes without even thinking. But getting it to work correctly as a piece of code is in fact more tricky than what it looks. It's very easy to create infinite loops or sometimes miss some corner cases and so on. In fact, if you do a search in Google, or let's say look at the literature related to binary search, you realize that very renowned experts have recognized that simple implementations oftentimes have bugs, right? So the approach we have taken is that, look, we will take a correct implementation of binary search. I'm referring to the book by Paul and Berman called Algorithms. In that I found a pseudocode for binary search. So the approach we'll take is to basically convert the pseudocode into Python code and then analyze it very, very carefully to first see how it works, to understand, let's say, the nuances of the code, and then see how things could possibly go wrong with, let's say, simple tweaks. So with this, my hope is that we'll get confidence in understanding what binary search is. How do we correctly implement it, and what are the things that can go wrong when we make simple mistakes, right? So I hope this will bring a lot of clarity to the entire discussion, and we'll continue with this in the next video. Do look at our website www.ybyte.in for more such content. We learn programming in a fun manner. We analyze things in detail, and we enjoy coding. Take care. Thank you so much. Bye bye.